All right, we're going to start today with a couple quick warm-up problems of where we left off our talk about factoring in section 5.2 last time. So just going to give you 90 seconds or so to do these problems right here. If you got any questions, where we left it is we're factoring trinomials, and everything we did was factoring trinomials with a 1 in front of the square. That's what these review problems reflect. And then we will talk about the situation of what happens if there's not a 1 in front of the square. So here's the first one. Let's say that you have something like this: x squared plus, let's go 12x plus 27, and then we have x squared minus 5x minus, let's go 36. All right, so let's do these two problems, and then here, let me give another review problem. I need to step out for just a second. So it's x squared. Let's do plus 4x, and then minus. Let's do plus 2x minus 12. Okay. Okay, so each of these problems, the way we talked about it is it's just a matter of figuring out what factors. So when you see there's a 1 in front of this x squared, this is the simpler situation. And so all you have to worry about is the lasts. What factors of the lasts are going to add up to this middle? So in this one, x squared, the two factors of x squared, what are my only choice? Only time I'm going to ask you. X and x. Okay, x times x is x squared. There's no other options. This plus on the 27, what does this tell me about my signs? Tells me they have to be the same, and then this tells me they're going to both be positive. Yes, that is correct. Both positive. The reason they have to be the same is this is my lasts when I FOIL. So I multiply to get the 27. And the only way to get positive when you multiply is either 2 positives or 2 negatives. So since they add up to a positive 12, and then what are the 2 factors of 27 that are going to add up to positive 12? 9 and 3 or 3 and 9, does not matter what order. Okay, so the check of this is 9 times 3 gives me 27, that's my lasts. 9 plus 3 gives me 12, that's my outers plus my inners. We're done with that problem. Here's problem 2, same sort of thing, x squared is x and x, I'll give you that part. This time on this problem, what do my signs have to be? One of each, right? This is a negative 36. Again, this negative 36, that's the result of multiplying my lasts together. The only way to get a negative when you multiply is have one of each. So a positive and a negative, or a negative and a positive. It does not matter which order in the least. Then after that, now I have to have the mindset of I need the 2 factors of 36 that are going to be 5 apart because they're going to have different signs. So when we add different signed numbers, we take the difference because they're going different directions on the number line. And what are the 2 factors of 36 that are 5 apart? Okay, 4 and 9. And the reason the 9 gets to be the negative one is because they should add up to a negative 5. Okay, so all these problems is just a review of some arithmetic. And so last one that I gave you, so I had to step out real quick, got a negative again, so a negative and a positive, positive and negative, it does not matter what order. I need the 2 factors of 12 that are 4 apart. That's going to be a positive 6 and a negative 2. Okay, the reason I use those instead of 4 and 3 or something else is because I wanted the ones that were 4 apart. And there we go. There are my review problems. So that brings us up to the present. So we're going to spend some time today finishing up section 5.2, and we'll get as much of 5.3 done as we can. So finishing up section 5.2, what we're going to do, what we're going to do is we're going to now factor trinomials. With we're going to factor trinomials with a number other than 1 in front of the x squared. Okay, so that's what we're going to do. So for instance, here is a lovely little problem. Let's say that I have this 3x squared plus 7x plus 2. Now, I'm sure at some point in your algebra past, because you've taken a bunch of algebra classes in your life, you have factored things. So if you have another method that you enjoy and that you're good with, please, by all means, use that method. I'm good with it. I am not going to be grading the method. I'm going to be grading the final result. Okay, so the way I'm going to show you to do this, our book calls, it's called the A times C method. Some teachers call it the box method. Others call it the California method. It doesn't matter what the name is, it's immaterial. But here's the process. So here's the process that we're going to employ. We are going to take advantage of something we learned last time, and it's kind of the reason that we learned it. What you're going to do, your first step, when you go to factor something that has a number other than 1 in front of the x squared, is you are going to multiply this first number and this last number. That's the first step. So 3 times 2, that gives me 6. And in fact, let me be a little more specific. Since it's a positive 3 and a positive 2, it is a positive 6. So that's the first step. Is you look at the firsts and you look at the lasts. We're going to multiply those 2 numbers together. Now, my question on this number is the same as we were just asking a moment ago. Okay, because remember, I have to now take into account this 3. I can't just ask what factors of 2 add up to 7, because that would be ignoring this 3 up here. So I've now taken into account the 3. 3 times 2 is 6. Now I ask, what two factors of 6 are going to add up to this middle number? 6 and 1. Okay, so I'm just going to make a little chart here, and I'm going to put a 1 here and a 6 here. 1 times 6. So I'm not going to use 3 times 2, because 3 times 2 only adds up to 5. And I want it to add up to 7. You tracking with me so far? I've multiplied the first and the lasts, and then I've asked myself the same question that we asked in the previous factoring is, what two factors of this new number add up to the middle? Now, what we do at this point, because we want to take advantage of something we already hopefully know how to do and have done a few problems, I'm going to now take this 1 and this 6, and I'm going to take this middle term, and I'm going to separate it into 2 terms. Instead of having 7x, I'm going to spread it apart. And so I'm going to have 1x and 6x plus 2. So I've taken the 7x and I've split it apart using these two factors right here. So a natural question that you might have is, hey, Perkster, could I have put the 6x first and the 1x second? The answer to that is yes. It does not matter at all what order you put these two terms. You can't mess it up. So again, I take the two factors of 6 that add up to 7, 1 and 6. And now the reason we've done that is it gives us the ability to use factoring by grouping. Okay, so this is the new part of the problem, getting to here. At this point, factoring by grouping, we looked at the first 2 terms, we looked at the last 2 terms. Out of the first 2 terms, I take what's in common. What's in common to 3x squared plus 1x? 1. Okay, I'm going to just write x, but yes, 1x. If you write the 1, that is fine. I don't mind. So 3x squared divided by x leaves 3x. 1x divided by x leaves 1. Out of the second pair of terms, what's left from these two right here? Or what's in common to these two right here? Yep, that is indeed true. 2. 6x divided by 2 leaves 3x. 2 divided by 2 leaves 1. And the grouping worked. So that's good news. And it will be good news. When you have your test in a week, okay, those of you who just came in, I'll give you a calendar. I've pushed the test back a day. So it's not going to be Wednesday. It's going to be next Monday. It gives us a little more time to practice factoring. And so everything on the test will be factorable. Okay, so you should be able to find pairs of factors for everything. And so now the grouping worked. I've got the 3x plus 1 in common. And then what's left from the first term is this x. From the second term, I have plus 2. You're welcome to FOIL this back together. You will get what we started with, but I'm just going to save us time, and I'm going to not check it. So here's one for you. Very similar problem. Okay, you multiply the first and the last, you get that number, and then you ask what two factors of that number add up to the middle. That's the key. So here's yours. 5x squared plus 13x plus 6. I'm just going to get us going with the first step. Okay, so what number are we going to be looking at the factors of.
Oh, wait, 30?
Yes, okay, so we're just doing this first step. So you've done the second step, so that's awesome. So what you're looking at, if you didn't know where to start, is you multiply the first and the last. 5 times 6, that gives you 30. And I'm going to leave you a little more time to keep working the problem. The next step now is what 2 factors of 30 are going to add up to 13, this number in the middle, okay? So keep working, and then you take those 2 factors and you split apart that middle term into 2 terms so that you can do factoring by grouping. That is the goal here. As I mentioned, I will say it again though, if you have another way to factor, if you learned this well in high school or in another class, you can use a different method. I really don't care. I am just showing you this method because it works every time and it takes advantage of something we've already done. All right, Kyle, I heard you say it. What are the 2 factors of 30 that add up to the middle?
10 and 3.
Perfect. Again, 10 and 3 or 3 and 10, the order does not matter at all, which way you use it. I'm just going to use them in the order that they were spoken to me. So I have 5x squared, and then I'm going to take this 13x, and I'm going to break it up into 10x plus 3x. So it's the same amount. I have just split it up. 10 plus 3 is 13x. And again, the reason I'm doing this is now I can factor by grouping. Okay, so I have a process, I have something that I can do the same thing every time that'll help us learn it. So if you don't have a way to factor trinomials, or if you don't have a way that works well for you, this is a great way to learn because it's a good process that will work every time and it'll allow you to do the same thing every time. So now I'll factor by grouping. So out of the first 2 terms, what can we factor out?
5.
A 5 and what else? You can always take out the smallest power of our variable, so an x as well. So 5x squared divided by the 5x leaves x. 10x divided by 5x just leaves 2. Then the second pair of terms, what's in common to 3x and 6? 3. 3x divided by 3 is x. 6 divided by 3 is 2. And then my last thing is to note, the grouping worked, so that's fantastic, good news. So I can factor out that x plus 2. And then from the first term, I have 5x left. From the second term, I have plus 3. And no matter what you did, whether my algebra teacher 30 years ago taught me to guess and check. So we just basically endured making a whole bunch of mistakes. If you do that, I don't know the name of it, but a student showed me their teacher had taught them something about dividing things out. I don't even think I could replicate it because I never learned it, but it worked. So that's great. However you did it, this should be the pair of factors that you're looking at. All right, here's another one, just so that we can keep practicing. Try this problem right here. It's the same sort of thing. And then I got one more problem that we're each gonna do another problem that involves different signs. So try this, 3x squared plus 23x plus 14. It will factor, so have perseverance. Grab your calculator if you need to, as you're looking at the factors. Okay, this will work. give you a start. The number we're looking at, 3 times 14. What's 3 times 14? 42. Now, you're looking for, or you've already looked for, the 2 factors of 42 that are going to add up to 23. Now, I know 42 is a little bit of an awkward number. So remember, start wherever you can. If you know a pair of factors that give you 42, I know 6 times 7. That does not add up to 23. You might see, oh, hang on, 42 is even, so you get your calculator out and you say, okay, how many times does 2 go into 42? And 2 goes into 42 21 times. Now that happens to be the right pair. 2 plus 21 adds up to 23. But if it didn't, you might go back up here and say, oh, hang on, 6 has a 3 in it. So go to your calculator. How many times does 3 go into 42? Well, we just see it right there. It goes 14 times. So break up whatever number you're dealing with, break it up into something that's more manageable, and then just use your calculator and play with the factors that you see. Okay, so with 42, I started with 6 and 7, and then notice that 2 goes into 6, and I got 2 times 21. This is the right pair of numbers. It's the right pair of numbers because I need the ones that add up to 23. So I have 2, 21, or 21 and 2. Does not matter at all what order that you put these in. So here we go. I've got 3x squared plus 2x plus 21x plus 14. Again, what did I do here? I took these 2 factors. 2 times 21 is 42, and I separated this middle term into 2 terms. It still adds up to 23, but now I have a total of 4 terms, and it allows me to employ grouping. So for my grouping step, first 2 terms, all that I can take out is an x. 3x squared divided by x is 3x. 2x divided by x is 2. Out of these 2 terms, 21 and 14, I can take a 7. 21x divided by 7 is 3x. 14 divided by 7 is 2. Once again, the grouping has worked, which is great news. And so when I factor out this 3x plus 2 from both of these, I have an x left from the first term and a plus 7 left from the second term. Here's another example for me. I'm just going to change one of the signs just to practice what happens when I have some negatives here. So let's try this one. If I have 12x squared minus 5x minus 2. I'm going to work this one along with you, okay, so you don't have to get going ahead. This is the first one that just has some different signs. So when I multiply my first and my lasts, what number do I get when I multiply the first and the last this time? Yeah, this negative is important. Okay, so make sure you observe that. That hasn't happened on any of the other 3 problems we've done. If you looked, it's been a positive value, so we've just kind of not been worried about the signs. But now I have 12 times negative 2, that is a negative 24. So it's the same sort of situation, though, that we asked ourselves on the simpler type of factoring when there's a 1 in front of the x squared. I want to know now what 2 factors of a negative 24. Well, if it's negative, that means one of the factors is positive, one's negative, or negative and positive. The sign doesn't, or the order doesn't matter. But what 2 factors of a negative 24 are going to add up to a negative 5? Positive 3, negative 8. Yes. Okay. What 2 factors of negative 24, since this is a negative number and they have different signs, what 2 factors of negative 24 are going to be 5 apart? And that is 3 and 8. And I make the 8 the negative 1 because the negative 1 wins. I end up with a result of negative 5. So once you get used to seeing the signs, that's the little bit of extra here. Now I'm going to take those 2 things. Again, it doesn't matter what order. I'm going to just use them in this order here, but you could reverse them if you wanted to. I'm going to have 3x minus 8x minus 2. So the 3 minus 8, that adds up to negative 5. So again, I've not changed the problem at all. I've just changed its structure a little bit so that it'll have 4 terms. Now I factor by grouping. Out of the first 2, I can take a 3. 12 and 3 have a 3 in common. X squared and x have an x in common. 12x squared divided by 3x is 4x. 3x divided by 3x is plus 1. Both of these terms here are negative, and I need them to both be positive, so I'm going to factor out a negative something. And what's in common to 8 and 2 is 2. So negative 8x divided by negative 2, a negative divided by a negative is positive 4x. Negative 2 divided by negative 2, again, a negative divided by a negative is positive 1. And once again, as should be the situation, especially on the test, the grouping worked. So I can factor out that 4x plus 1, and then what remains of the first term is the 3x. From the second term is the minus 2. There's my multiplication that when I FOIL it, I will get this thing right here. All right, here's a problem for you. Involving these different signs, so you get to practice a little bit. So try this one, 8y squared minus 10y minus 3. Same thing that we just did, just the signs different. What number are you looking at the factors of? Yep, 8 times negative 3. Okay, the first and the lasts. Okay, so keep working. I just wanted to make sure we're all starting in the same place. 8 times negative 3 is negative 24. So your next question, don't answer it yet. Let's get everybody think about this. The next question is, what factors of negative 24, so they have different signs, what factors of negative 24 are going to add up to negative 10? So that's where you are now. So keep working. All right, what are the two factors of negative 24 with different signs that are going to add up to negative 10? Negative 12, positive 2. Fantastic. I'll use them in that order because that's the order they were spoken to me. If you use the positive 2 first and the negative 12 second, totally will end up with the same thing. So here we go. 8y squared minus 12y plus 2y minus 3. Again, I took the two factors I was given and I used them to separate this middle term into two terms that are equivalent. Now I will factor by grouping. First pair, last pair. Out of the first pair, what can I take between the 8y squared and the 12y? What's in common to those? Y and 4. Yes, I heard different people say both of those things. That's great. 8y squared divided by 4y. 8 divided by 4 is 2. Y squared divided by y is y. Negative 12 divided by 4 is negative 3, and then I factored out the y. I don't need another y. Is there anything in common to these two? A 1, yes, and you notice, oh, 2y minus 3, that's the same thing that's already in parentheses. So I'll factor out the 1, that's fine. 2y divided by 1 is 2y. Negative 3 divided by 1 is negative 3. My grouping once again worked. I've got the same exact thing in the parentheses. That's good news. So I take the 2y minus 3. What's left from the first term? 4y. From the second, plus 1, and we're good to go. Here's one more example, because I want to show you something that you're going to see on your homework when you go through. And my math lab likes to kick in a few of these for whatever reason. So I don't want you to get stumped on something like this. Let's say we have a negative 6r squared minus 13r plus 5. When I have a negative in front of my square term, it sometimes just makes the thought process a little confounding. And so what you're going to be recommended to do is, before you worry about going through any of this junk right here, what we're going to do is we're going to factor that negative out, so I don't have to deal with it. So we talked about this on last class, or if you're watching the video, it's on the last video. So do me this favor first, do the first step, factor out the negative, and then write what's left in the parentheses. Okay, so that's step 1 of this problem. Factor out the negative, and then what's left. I'll give you 20 seconds to write that down when I factor out the negative. Okay, when we factor out the negative, what's the first term going to be now? What's the middle term going to be? And what's the last term going to be? Excellent. And so now, forget about the negative, just cover it up. We'll talk about what to do with that or anything else you might factor out at the end. And then I want you to factor this, 6r squared plus 13r minus 5, do it in the same way we've done the previous problems. Okay, so now we're just factoring this stuff that's in the parentheses. All right, so I'm going to get started on this. Wherever you are in the work, keep working. So whatever you factor out, if there, and we're going to talk about this, there's one more thing from this section we're going to mention after this problem. Whatever you factor out is just going to come be part of the final answer. So I'm just going to draw a little arrow. If you get to the final answer, it will have a negative in front of it. I'm not going to worry about that right now. Okay, what I'm going to worry about now is this stuff in the middle. I want to factor that. So first thing, the 6 times the negative 5, 6 times negative 5 is negative 30. So hopefully you then ask yourself the question, what two factors of negative 30 add up to positive 13? Negative 2 plus 15, great. If you wrote down 10 and 3, I totally understand why you would write that. But remember, these have to have different signs. And 10 and 3 only add up to 13 if they have the same signs. Okay, they would not be the appropriate factors for this one. So make sure that you pay attention to the signs. That's why I picked this problem as the last one. Just want to make sure that you're taking that into account. I know there's a lot of details, and that's why I added an extra day for the factoring. I didn't want to rush through all that. Okay, so negative 2 and plus 15, negative 2 times positive 15. When I multiply them, I get negative 30. And when I add these two numbers, I get plus 13. So that's great. So now I'm going to use those two right there in whatever order. 6r squared minus 2r plus 15r minus 5. So negative 2r plus 15r still adds up to 13. And I've just given myself now 4 terms. So now I will factor by grouping. I'll group the first 2. I'll group the last 2. Out of the first 2, we can take a 2 and an r. 6r squared divided by 2r leaves 3r. Negative 2r divided by 2r leaves negative 1. What's in common to 15 and 5? That'll be a 5. 15r divided by 5 is 3r. Negative 5 divided by 5 is negative 1. And once again, we see that the grouping worked. So I have 3r minus 1. And then what's left from the first? 2r plus 5. So we factored the thing in parentheses. Now just, if you, I drew my arrow a little far. So all we have to do now is remember that we have this negative. So this negative, you can't leave it out. It's part of the final answer. Okay, what I have here now has to, when I multiply this out, has to give me that. So I need that negative out in front. Okay, that's the last step to do. Last thing from section 5.2 on factoring. And again, like I mentioned last time, please just practice this. It will be so helpful to your math future if you practice this not only in Unit D. Unit D is 80% factoring. If you can factor, most of the stuff is pretty relaxing in Unit D. And then when you get to college algebra, okay, we don't talk about factoring again, but I expect you to know how to do it. Okay, so you'll have problems, and I'll say factor this, and then hopefully you have remembered this. Okay, so here is the last problem. 5w to the third minus 40w squared, and then plus 60w. So sometimes you're gonna encounter a problem that has a number in front of the first term, but before you go through all of this mess right here, always make sure you factor out any common factors. We always just want to work with the smallest number possible. So I'm just going to make a little note, and that is the purpose to this problem. Anytime you are able, factor out a common factor. Okay, so always factor out the common factor first. Because what's going to happen on this problem is going to take this problem that, oh, you're thinking 5 times 60, that's 300, and that's a lot of factors to look at. Before you go into all of that, if you factor out the common factor, this problem is going to be a little more timid. So that's what I would like you to do. I'm going to give you a minute or minute and a half. First, factor out what these 3 terms have in common, and then factor what's left. Okay, factor the trinomial that's left. So 2 steps on this problem. just so we're all working in the same direction, what is the common factor among these three terms right here? 5. And also, yep, always take out the lowest power of any variable. So 5 and w. Okay, so now that once you factor out the 5 and the w, you're going to have a trinomial in the parentheses. So then step 2 of this problem is to factor that trinomial however is appropriate. So when I take out the 5w to the third, when I factor out the 5 and the w, that leaves me w squared. So what we've done is this problem, even though at the beginning it looks like it has a number that's not 1 in front of the first term, once we factor out the common factor, it becomes a much easier problem. Okay, there's just a 1 here in front of the squared term. Negative 40 divided by 5 is negative 8. 2 w's, I factored out one of the w's, that leaves w. Then 60 divided by 5, that turns out to be 12. There was one w, I factored out a w, so we're good. So remember this 5w here, this is part of the final answer. So however many steps it takes you to do this, just remember this has to be part of the end. Okay, there will be on the test a deduction if you've done all the work right, but then in your final answer, you don't have all the factors. Okay, I'll give you credit for doing work well, but make sure that you end on the right result. So this has a 1 in front of the squared term. So w squared is w times w. The positive 12 tells me the signs have to be the same. Here it tells me they're both negative. And then the two factors of 12 that add up to 8 are 6 and 2. And then this 5w, it's part of the answer, so I'm going to put it out in front. And if you wanted to take the time, multiply these three things back together, you will get exactly what we started with, and that's the goal.